Hello students, welcome to this video session. I remain Samuel Chukwu Ebeka, aka Samdom For Peace. In this video session we shall add and subtract mixed numbers. This is a fractions part 4, so it is in a playlist. Please, it is highly recommended that you view the videos in the playlist in order. We have talked about mixed numbers in previous videos. Today we shall now do some arithmetic operations of addition and subtraction on mixed numbers. So we shall look at, we have the problems here on my left hand side. We shall look at the question, and as usual, I like teaching multiple ways, multiple methods to solve a problem. So I shall teach you two methods to solve this problem. And whichever way you prefer, you choose. Let's get started. Question 1, we have to add 2 whole number 2 over 9 plus 1 whole number 2 over 15. First method, what we can do is we add the whole numbers first. A mixed number has the integer or the whole number and the proper fraction. That is what a mixed number has. It has the integer and the proper fraction. So we can, first method, we add the whole numbers first. 2 plus 1 gives us 3. And then we now add the proper fraction. Okay, we have a 2 over 9 plus 2 over 15. So I like using vertical method when I solve a proper fraction. So I'm going to write it like this: 2 over 9 plus 2 over 15. So I draw my line here, 9 and 15, they do not have the same denominator, the two fractions. 9 is not equal to 15. So these two fractions have unlike denominators. So what do we do? In previous videos we talked about it. We find the LCD, least common denominator. So what's the least common denominator of 9 and 15? That gives us 45. So I put 45 here, 45 here. What will I do to 9 to give me 45? Multiply by 5. Whatever I do to the denominator, I do to the numerator. So the equivalent fraction is 10 out of 45. What will I do to 15 to give me 45? Multiply by 3. Whatever I do to the denominator, I do to the numerator. So the equivalent fraction of 2 over 15 with 45 as the denominator is 6 over 45. See that? So now they now have the same denominator. I only need to write it one time now. And this will be 10 plus 6. And this gives me 16 over 45. So I have this now. I have this 3 and I have 16 over 45. So all I need to do is I just combine it, period. Now this is the plus, okay? And I added this, and also I added this plus. So now I just join them. That's all I need to do. 3 plus 16 over 45, and that gives me 3 whole number 16 over 45. And this becomes our answer. This becomes our answer here. 3 whole number, 16 over 45. Okay, that is the first method. Now, let's go to the second method. Second method. With the second method, you have to convert it to improper fraction first before you add. Okay, with second method, convert the mixed numbers to improper fractions. Then add them. That's the second method. Remember, the first method, we just add the integers, add the proper fractions, and then add them together. Second method, we've got to convert it before we add. So we look at 2 over 9. This gives us 9 times 2 is 18, plus 2, 20 over 9. And then we look at 1, 2 over 15. 15 times 1 is 15, plus 2 is 17 over 15. So now we have 20 over 9 plus 17 over 15. The fractions do not have the same denominator, so I have to express them to have the same denominator. And the least common denominator is 45. I've got to multiply this by 5, and whatever I do to the denominator, I have to do to the numerator. So the equivalent fraction here is 100 over 45. Here, I've got to multiply by 3. I've got to multiply 15 by 3 to give me 45. And whatever I do to the denominator, I do to the numerator. So the equivalent fraction is 3 times 7 is 21, 1, 2, 3 times 1, 3 plus 2, 5. 51 over 45. And then I can add it up. I can add both of it up. Here, 100 plus 51, and that gives me 151 over 45. Right? 151 over 45. So I will now have to start, I divide this, 45 into 151. 45 times 2 gives you 90. 90 plus 45 gives you 135. 135 plus 45 gives you 180, which is past this. If you divide this, 45 divided by 151. 45 times 1 is 45. Add 45 again, 90. That means 45 times 2. Add 45 again, 135. That means 45 times 3. Add 45 again, 180. That means 45 times 4. It's past it. So 3 times 45 will give us what? 135. Okay? And then you subtract. 11 minus 5 is what? 6. 4 minus 3 is 1. So this will now be 3 whole number, 16 over 45. Just like what you have. Now, my advice to you is this. If you're given the problem in mixed number, leave your answer in mixed number. If you're given the problem in improper fraction, leave your answer in improper fraction. If you're giving your questions, the numbers as proper fraction, then leave your answer as either, if it works out to be proper fraction, that's fine. If it works out to be improper fraction, that is fine. Some learning software grade improper fractions. If it works out to be mixed number, that's fine. But if you're giving your problem as mixed number, try to leave it as mixed number. Now, some textbook, some learning software, learning management system or cost management systems will grade improper fractions as the answer. Some of them, some will grade it like this, 151 over 45. Some. Okay, let's do the number 2, question 2. Question 2, we have 6 1/3 plus 3 7/9. So with first method, I just add the integers. 6 plus 3 gives me 9. Then I will add a 1 over 3 plus 7 over 9. So I like doing it in vertical form. 1 over 3 plus 7 over 9. LCD is 9. LCD 9. So this is times 3 times 3. This will give me 3 over 9. This will be times 1 times 1. This will give me 7 over 9. So this becomes what? Over 9, 3 plus 7 over 9. And this gives me what? 10 over 9. Okay? Improper fraction. I want to leave it as mixed number because I don't want to write 9, 10 over 9. So this will be what? 1 whole number, 1 over 9. So now, what do I do now? What I do now is, I come and I add 9 plus 1 whole number, 1 over 9. And that will give me, of course, 9 plus 1 is 10. 10 whole number, 1 over 9. And this becomes my answer. If I have 6 1/3 plus 3 7/9, I convert to improper fractions first. 3 times 6 is 18 plus 1, 19 over 3 plus 9 times 3 is 27 plus 7, 34 over 9. I like doing mine in vertical form, vertical method. 19 over 3 plus 34 over 9. The LCD will be over 9 over 9. 3 to give you 9 will be times 3. Then also this will be times 3. 3 times 9 is 27. Carry 2. 1, 3 plus 2, 5. 9 times 1 times 1. Then they now have the same denominator. I bring out 1 time. 57 plus 34. And this will now give me what? 7 plus 4 is 11. 1 plus 5, 6 plus 3, 9. 91 over 9. Okay? 9 into 91 is 10. 10 times 9 is 90. Remaining 1. 1 over 9. 1 over 9. This becomes your answer. That's it. Okay, let's go to number 3. Question 3. 4 3/4 minus 1 2/5. The same method applies with the same way we did the addition. That is the same way we do the subtraction. However, this is what we are going to do here. We are going to subtract the integers. Then we will also subtract the proper fractions. Then we won't subtract again. No, we will add whatever we get. Yeah. You don't do subtraction multiple times. No. Okay. So first of all, we do 4 minus 1 gives us 3. Those are the integers. Then we do a 3 over 4 minus 2 over 5. I like writing it vertically. So this is a 3 over 4 minus 2 over 5, 2/5. So the LCD of 4 and 5. LCD of 4 and 5 will be 20. 20. 4 times 5 will give us 20. And the same thing times 5 here is 15. So the equivalent fraction is 15 over 20 for 3 over 4. 5 times 4 gives 20, then 2 times 4, 8. The equivalent fraction is 8 over 20. And then I can subtract it. Both of them now have 20 as the denominator. 15 minus 8. And that will give me 7 over 20. So I got this 3 and I got 7 over 20. So what is my answer now? My answer will be 3 plus 7 over 20. Please don't come and start doing 3 minus 7 over 20. No. That won't work that way, no. You don't want to do subtraction multiple times. Subtract the integers, keep. Subtract the fractions, keep. Add it. And this gives us what? 3 whole numbers, 7 over 20. That's it. That's it. You know, when you are adding integer with a fraction, you don't need to come and start writing, trying to make that integer like a fraction. Like some people will do 3 over 1 plus 7 over 20 and try to do the LCD. Come on. Just add it like that. 3 whole number, 7 over 20, period. Like that. Okay. So let's do this with the second method. Four whole number, 3 over 4 minus 1 whole number, 2 over 5. As usual, we'll convert it to mixed number. 4 times 4 is 16 plus 3 is 19 over 4 minus 5 times 1 is 5 plus 2, 7 over 5. So I have a 19 over 4 minus 7 over 5. LCD is 20, 20. This will be times 5, times 5. 19 times 5 is 95 over 20. This will be times 4, times 4. 7 times 4 will be 28. So I now have over 20, I have 95 minus 28. And that will give me what? 15 minus 8 is 7. 8 minus 2 is 6. 67 over 20. 67 over 20. 20 into 67 is going to give us 3, because 20 times 3 is 60. 3 whole number, 7 over 20. This becomes an answer. Question 4. I'm trying to do varieties. Question 4. 6 whole number, 1 over 4 minus 5 whole number, 1 over 3. With this first method, I do a 6 minus 5 gives me 1. Then a 1 over 4 minus 1 over 3. We do it vertically. 1/4 minus 1/3. Our LCD is 12. So this is over 12. This is over 12. 4 times 3 will give us 12. 1 times 3, 3. Equivalent fraction is 3 out of 12. 3 times 4 gives us 12. 1 times 4, 4. Equivalent fraction, 4 out of 12. Equivalent fraction. So this will now give us over 12. We have 3 minus 4. Right? Which is what? Minus 1 over 12. Okay? Minus 1 over 12. So just the same way we have it. Okay? You don't panic because you got a negative here. That's fine. We'll still do it the same way we've been doing it. 1 plus minus 1 over 12. I did a video on plus minus. Well, I did a video on that, integer operations. It is important you do that video. Plus minus will give us a plus minus, which is minus. This is the same thing as writing 1 plus minus 1 over 12. It's the same thing as writing it like that. It's the same thing, which is now 1 minus 1 over 12. Now you can do this 1 over 1 minus 1 over 12. You do it as another fraction again, you know, or 1 is pretty much straightforward. 1 means 12 over 12. So this is 12 over 12 minus 1 over 12 to be the same denominator, and this will give us 11 over 12 as our answer. 11 out of 12. Now with addition, you can easily join them like that. 1, if it was 1 plus 1 over 12, it will give us 1 whole number, 1 over 12. But if with subtraction, you need to solve it as usual. You can do this. You can write it. You can write this as 1 over 1 if you want to. You write 1 over 1. You can do that, and then find the same LCD. Yeah. Usually with 1, I know is that over 12 over 12, which is that. Yeah. Otherwise, you can still use the vertical method. We can do it. Okay? We can still use the vertical method and solve it. 1 minus 1 over 12, which is 1 over 1 minus 1 over 12. And this over 12, this over 12. This times 12 times 12. 12 over 12 times 1, 1 over 12. And you do 12 minus 1 over 12, which is 11 over 12. Whichever way. Okay? So let's do the same question with the second method. 6, 1 over 4 minus 5, 1/3. Remember, we add these, not subtract. It's just that this came out to be subtraction. Okay, this means 1 plus minus 1 over 12, which was still 1 minus 1 over 12. Plus minus is minus. Yeah. Okay, with the second method, if we convert this to mixed number, 4 times 6, 24, plus 1, 25 over 4, minus 3 times 5, 15, plus 1, 16 over 3. So we have 25 over 4 minus 16 over 3. So our LCD is over 12 here, over 12 here. This is times 3, times 3. This is 75 over 12. This is times 4, times 4. This is 64 over 12. And then we can now, all of them will be over 12. 75 minus 64. And that gives us 11 over 12. The same thing. 21 minus 18 whole number 1 over 2. 18 and half. 18 and 1/2. If you're going to use this first method for this, you have to be careful. Okay? You see that there's no guy here. There's no guy here. So with this first method, you can actually do it 2 ways. You can do it 2 ways. First way, you can say, okay, subtract 1 here. So this will be 20, and I'm going to circle this 20, so that this will be like 2 over 2, This is like saying 20, it's like saying this. It's like saying that 20 means 20 plus 1, which is 20 plus 2 over 2, right? Which is 22 over 2 minus 18 1 over 2. It's just like, I will teach you several ways. So I have another way to do this, so whichever way you like, that's fine. But if we're going to do this way, then we now do 20 minus 18, and that gives us what? 2. And then we do 2 over 2 minus 1 over 2, and that gives us what? 1 over 2. And then we can add it. We can now add it. 2 plus 1 over 2 gives us what? 2.5. And this becomes our answer here. This becomes our answer. Or, if you don't like what I just did now, right? You can have 21, to be 21, 0 over 2. How about this? I mean, you've got to put something here. So it's like saying 21 plus 0, okay, which is now 21 plus 0 over 2. You can say 21 plus 0, which is now 21 plus 0 over 2, which is now 21, 0 over 2. You can still do it this way. It's going to work. We'll see. If you do it this way, let me kind of draw a line here. If you're going to do it this way, then you have 21 minus 18. That gives you what? 3. And then you have 0 over 2 minus 1 over 2. And that gives you what? Because it's all over 2, 0 minus 1, which is minus 1 over 2. And then you can add. Okay? You can now add 3 plus minus 1 over 2 will give you 3 minus 1 over 2. And that will give you 2.5. If you do it like 3 over 1 minus 1 over 2, still gives you 2.5. Still gives you 2.5. Okay? So, how you want it is up to you. How you want it is up to you. If we use the second method for this, we have 21 minus 18, 1 over 2. This 21 is already 21. We can call it 21 over 1 because we want to express this as an improper fraction. Although, you know, that's what we want. That's the second method. Minus 2 times 18 is 36 plus 1, 37. 37 over 2. So I will now have, because I like writing this as in vertical, 21 over 1 minus 37 over 2. LCD is what? 2. LCD is 2. What will you multiply this times 2? So this will be times 2. And this gives us what? 42 over 2. As the equivalent fraction. This will be times 1, and this is 37 over 2. So this gives us what? 42 minus 37 over 2. Which is what? 12 minus 7 is 5. 5 over 2. Which will give us what? 2 whole number 1 over 2. Same answer. Whichever way you like, you choose. And we will stop here for now. Watch out for more videos on fractions. Okay? Thank you so much for listening, students. And whichever way you like, you choose. Have a great evening.